noise. Let's see if this still works. I'm streaming in like 2 weeks. Oh, looks like we're live. Boom. Okay, we're going to share this out. I'm going to pop out the Twitch chat. And then minimize a whole bunch of things so I can organize it. If you're joining the chat, please let me know if you can hear correctly. But we have an exciting stream today. We are going to be talking about why forecasting is BS. BS stands for bull. I don't know if you're allowed to swear on Twitch, but I don't need to swear. You can infer that yourself. You're smart enough. So let's just share this out on the Twitters. Twitch.tv/Mr. D Burke. Am I live? .tv. Boom, we're on. Okay. Look, this is what I get. Not interested in this ad. I would pay like $5 a month so that Twitter doesn't show me ads. But let's write this out. Going live on Twitch. Already live on Twitch. Discussing and writing code for the turkey problem. We need the turkey emoji here, of course. Hey, Sally, what's good? Yeah, you're right. I haven't streamed in 2 weeks. I've been busy writing a lot of materials for the time series. We're going to get into that in a second. I'll finish this tweet and then we'll discuss what we're doing for the turkey problem and why forecasting using machine learning models for forecasting market prices is BS. Come and say hi, and we'll get a little wave emoji. Wave. I found I couldn't write very well live on stream, so we're going to practice that today. Come and say hi. Wave. Discussing and writing code for the turkey problem. What is that? Why using machine learning models for forecasting market prices is BS. Boom. All right, that's done. Hey, Jeff.Dash, what's good, my friend? I'm going to get off there. This is a great article, by the way. 3 facts about time series forecasting that surprised experienced machine learning practitioners. Here's what we're doing today. If you want the code, you can all see it there. I'll just link you the notebook in the chat. Copy link address. This is all the code here. We run that. Now, I have to run this to where we are. Oh. But here's what we're doing. Right, so let me give a little bit of background. This is the final module for my TensorFlow course. And it's time series forecasting with TensorFlow. And it's actually kind of like an anti-module because it shows you just how poor machine learning models are for forecasting. So what we're trying to do in this project is predict the price of Bitcoin. But as we'll see, and if you go through the notebook, you'll see that most of our models actually do pretty poorly. And we're going to see just how poorly it will do by changing a single data point. But here we go. We have Jeff.Dash says, Daniel, I've been using your Udemy course to practice TF. Thank you for your work. Oh, thank you, Jeff. Well, we're building the last module right now. This is going to be the last notebook of the course. This one here. I've been working on it for about a month or so now because I could have just pumped something out of how to just quickly write a model for forecasting, but that's not my style. I want to teach you the things that I think are most important to keep in mind with any kind of machine learning system. Building a model, you can build a model for almost anything, but that doesn't mean you should use it. You can build a machine learning model for almost anything. However, it doesn't mean that the model will perform well. Jeff says, you're an inspiration to me, and I'm sure a lot of others are on this journey. Oh, thank you, my friend. I really appreciate that. Sally says, just came up with an idea to team up and dive into Kaggle. Siobhan says, hey Dan, what's good? Where have I been? Where have I been? I've been here, my friend. I have been writing. This notebook is possibly one of the biggest in the whole course. I've been writing all the materials for this. This is what I've been doing. I found that I wrote all the code live on Twitch, but I found when I was writing it to explain it, I just needed no distractions so that I could explain it really well. So I've been writing code for this, writing text for this, researching for this. That's what I've been doing for the last 2 weeks. I had to just be solely focused on one thing, and it's almost finished. We're up to the last little part here. So this is a huge notebook, possibly too big, but that's okay. It's got everything, well, some of the most important things that you'll need to know for time series forecasting with TensorFlow. The main one being that with an open system, machine learning models basically don't work. And I have a great story in here, actually, which is uncertainty in dating. I went on a radio show the other day called First Date Feedback, and you go on a first date with a girl. She's a very pretty girl, and the whole date is recorded via audio, so it's kind of a bit of fun. The story's here, and then halfway through the date, the girl gives feedback to the radio host saying how you're going, and then at the end, they also give more feedback saying how it was at the end. And then you go on the radio, live on the radio the next day, and they play you the feedback, and they tell you what you did right and what you did wrong. But I don't know if I did anything right, because the feedback was pretty full on. But I've got the audio file for that, so let me know if you'd like to listen to that. It's quite a laugh. Ayo, Nell Maxwell, what's good, my friend? Arthuro says hi as well. Okay. Oh, thank you, Siobhan's. You're a pretty man. You have to be careful of flattery, though. You might trick yourself. All right. So let's get on to the topic of the stream is the turkey problem. Now, what is the turkey problem? Let's Google this. Turkey problem. Images. Here we go. So this is the turkey problem in a graphic, and we're going to reproduce this for predicting the price of Bitcoin. So say you're building a machine learning model to predict whatever this is, a stock price going up. You're trying to predict whether the stock price will go up, or in our case, we're trying to predict what the price of Bitcoin is. So you could train a model on all of this historical data, but you could have one data point. So when Thanksgiving comes around for a turkey's life goes really well for its first 1,000 days. And then Thanksgiving comes around, and the turkey, well, its well-being isn't so good after Thanksgiving because, of course, it goes to the slaughter and it gets served on the Thanksgiving dinner table the next day. Now, what does that mean if we translate that to predicting stock prices? If we were to predict the stock price of Bitcoin or the market price of Bitcoin over 1,000 days, and our model is doing really well, we made money every day for 1,000 days, we would then have, if some unknown event happened, our model cannot predict this type of event. Why? Because it is not part of the original distribution. So we could make money for 10 years straight on Bitcoin, and then we have one day where we lose everything. So you could have 10 years of making $100 a day, and then you have one day where the price of Bitcoin drops to like $5 and you lose all of your money in one hit. So that is really important to know with forecasting models, is that they can never predict something that's outside of their distribution. So keep that in mind. We're going to see this firsthand in a minute. Where did the turkey problem come from? This is from Nassim Taleb's book, The Black Swan. I'm not actually sure if I can show this, but we're going to do it anyway. I've paid for this book, so if we go here, this is The Black Swan. Highly recommend this book. So let's search turkey problem. Turkey problem. How to learn from the turkey. Can you see this? Sally says, will I start ML Ops soon? Yes, you're right. That's my next journey. So Siobhan's, all of my ML courses are through ZTM. Yeah, exactly. So Null Maxwell is saying that the turkey problem happened to him in an internship with forecasting gas prices right before US prices went negative. Yeah, so let's look this up. US gas prices go negative. Do we have a graph of this? Yeah, look at this, right? So how could you possibly build a model to predict that? I just want you to think about this. Like, you don't even need to know much about machine learning or any kind of forecasting. You know this intuitively. You know this intuitively with your own life. So think about the most significant events in your life and whether they were predictable or not. So say, for example, when you meet your significant other, right? If you retrace the events back to meeting that particular person, it could be any person. It doesn't have to be your significant other. You could walk into a random cafe one day and you find that the person serving is very pretty and you decide to ask them out on a date and they say yes, and 20 years later you're still married. So you could never predict that type of event. So the same thing goes with forecasting. Now, look at the historical data here. There's 20 years of the prices jumping up and forth, like between $25 and $150. There is never once in that whole entire 20-year history where the price goes negative. So you're telling me you're trying to build a model to predict the price going negative despite it never happening in the history of oil prices. Now, of course, this is a very unlikely event. However, most often, it's the unlikely event which has the most significant impact on you, right? So same thing in daily lives. It's the most significant events in your life are completely unpredictable. In fact, I don't want to be able to predict them, because if you know the future already, that's already the past. So let's just debunk basically every tutorial you see where they claim to be using machine learning models to forecast stock prices. Because again, now I want you to think of this, where some people might get lucky and make money. Why is that? Well, if you have 1,000 machine learning engineers out there building models to predict the stock market, simulate this, right? 1,000 of them, and they each train slightly different models. You might get 1 out of 1,000 that has a lucky streak and makes money 10 years in a row. And you'll hear about that person because everyone loves to share when they've won, but you won't hear about the 990 machine learning engineers that went broke. So that's silent evidence. So now let's start writing some code. Oh, I think I've already written the code. Yeah, I have. Okay. So let me show you the historical price of Bitcoin, what we've got. We've only got the prices up till May 18th, so it doesn't really matter. The principle still stands. If you want to go up here, and let me know if anything what I've said is making sense. I wrote a great area of uncertainty in machine learning as well. If someone wants to read that, that would be great. Uncertainty in dating, there's a fun story there. Maybe I'll link the audio here. You can hear me getting roasted on the radio. But this is aside the point. We've got to keep things technical. This is still a work in progress. Today is the 17th of June. And I want to show you the data set that we have. Where did I plot it? Yeah, okay. So here's the historical price of Bitcoin. This is what we've got. We downloaded some data from CoinDesk, I believe. Is it CoinDesk? What is the price of Bitcoin right now? Price of Bitcoin, 50,000 Australian dollars. CoinDesk. So CoinDesk allows you to export this data. It's now 38K USD. You can download it as a CSV. Yeah, here's what we got. So it starts in 2014 and it goes up a bit in 2018. No. It goes right up at the end of 2021, and here's where we are. This finishes at May 18th, all right? May 18th, 2021. We could, of course, get the latest data, but we're just going to play with this data set. So there we go, price of Bitcoin. So now you know what we're talking about. And if we go down to our turkey model, all I've done with this code here is I've got the data. So this is a zoomed in plot. It starts at the end of 2020. And all I've done is I've changed one data point on this entire graph. Just changed one single data point. What I did was I pretended that the price of Bitcoin fell 100x in one day. Of course, that's an outlandish, you would never think that that would actually happen. But as I said, it's often the things that you think will never happen, the black swans, hence the title of Nassim Taleb's book, which I would highly recommend. It's often things that you think that could never happen that influence you the most. And so it's just something to be aware of. So if we get the last 10 prices of Bitcoin from our historical data, as I said, we've just manufactured one of the last prices to be 100x smaller than what it was. So if you just times this number by 100, you'll get the original price of what it actually was. And so we're just waiting for the rest of this notebook to run because up here we've trained a few models. We re-implemented the NBeats algorithm. Maybe I should make this a bit larger. Oh no, this can be... We created an ensemble. We made predictions into the future, but they're also quite bad. You'll see all of this in the notebook. Make predictions on the future. Let's predict the future and get rich. Maybe not. Trust me, if machine learning models did any good for being able to predict the future stock prices, you would see a lot more people making a lot more money. I agree, Siobhan's, that beautiful, the most impactful life events are the most unpredictable. This must be a quote, yeah. You can quote me on that. I'm probably just remixing something I've heard somewhere else. But yeah, as we see, this is predicting the future price based on our historical data. It seems that our model eventually overfits. I'm not going to go through this because you can go through the notebook yourself to see this. This stream is focused on the turkey problem. But let's have a read while this code is running. Oh, I think it is running. Okay, wonderful. All right, well, let's go through this. As I said, all I've done, I've kept the entire historical data of Bitcoin. We have about 10 years of Bitcoin data. All I've done is I've changed the single last point to be, instead of $43,144, it's now $431. Does this make sense? Who knows? But does this make sense? No, hell no. As I said, the most impactful events won't make sense. You cannot predict them. By principle, you cannot predict them. So we'll add an extra day to our time steps. Bitcoin time steps. We'll plot the figure. Turkey problem. Boom. Okay. So this is the exact normal historical data of Bitcoin except for the one last data point. That is what I just want you to keep in mind. All we've done is we've changed one single data point in our entire data set. So this is just we go back to the turkey problem. The exact same thing that's happened with a turkey in real life. Its life is going great until one single day gets changed. And that is, it's grown big enough for Thanksgiving. And so we go back here, we're going to create some windowed data sets, which are just, we use the last 7 days of Bitcoin data to predict the next day. That's what I mean by making a windowed data set. We have a look at our model 1, which is just a simple dense network. So these are the figures we're going to we're going to compare our turkey model to. So it's MAE. On average, it is, in terms of our model, it is wrong by $568 when it predicts on the test data set. There's some other metrics there, but MAE is probably the most intuitive to just think of. So let's see how much changing one data point affects our model. So all I'm going to do, I have the same model here, same model architecture. Turkey model, I'm going to clone our original model 1. So if you want to see model 1, we can go up here. It's just literally a one-layer dense network. Here we go. Model 1. Nice and simple, right? TF-Keras sequential. It's got a dense layer, 128. Relo activation. Output layer is a dense layer. Horizon is, we're trying to predict the horizon number of steps. So as I said, our data at the moment is we use a week worth of Bitcoin data to predict one day into the future. And we do that over and over again for our entire data set. And so if we come back down here to our Turkey model, we just copy the same model architecture, same loss function, same optimizer, 100 epochs, validate, and we'll run it. Yes, this is, Siobhan's asking, this is raw milk. This is, well, it's close as raw milk as you can get in Australia without actually going to a farm. Wonderful. So now we're going to evaluate the Turkey model on the test data set. We'll reload in the best model because the loss fluctuates a fair bit. So that's what we've done here with just to create model checkpoint. That's going to help us just reload in the best performing model. We'll make some predictions with our model. I've got a function here, make preds. Basically, that just takes the test data set features and makes Y, predicts Y. Now, let's evaluate the Turkey predictions. Look at this. And just one value change, our error metrics go through the roof. So if we remind ourselves of Model 1 results, which were the exact same, Model 1 is the exact same architecture as the Turkey model, but have a look at how much the MAE increases. One data point, we changed one single data point in the entire data set, and now we have an MAE of whatever that comes out to. Is that something like 15x? 30x. So it's about a 30x increase. 15, what am I? Am I joking? I can't do math. So we have a 30x increase in the MAE by changing a single data point in our entire data set. So as I said before, this is why forecasting is largely a bunch of BS. Is because you could make money every single day on your Bitcoin model. And then you have one crazy day where something happens, like the internet goes down or something, I don't know. This event that you can't predict, and you lose everything you've made over the past 10 years. So be very, very careful of anyone who claims that their model, and as I said, build me a model that can take in this data and predict this data point. Right? Build me a model that can do that. If we go back to the example that Maxwell gave us, is the historical price of oil over the last 20 years never once went negative. So you're trying to tell me that you can build a model that's going to go, you know what? Based on the last 5 years of oil prices, it's going to go to negative $25 a barrel. Try and build a model to do that. What I'm saying here, the point is, your model cannot predict something which is outside of the original distribution of data that it was trained on. So if we go down here, and if we compare all of the previous models that we've done, if we want to plot the predictions, look at that. Our model predicts this. It does not have a chance to predict this. That one crazy day you had. And if we compare all of the models that we've trained 10 models throughout this. The most important is probably the naive model, because what does a naive model do in forecasting? The naive model simply predicts the next time step as being the previous time step. And so with market prices, you'll actually have a very hard time beating the naive model. Why is that? Well, it's because of autocorrelation. What autocorrelation is, autocorrelation refers to the degree of correlation of the same variables between two successive time intervals. Beautiful. Between two successive time intervals. So it means that the price of Bitcoin today is probably going to be closely related to the price of Bitcoin tomorrow. And so hence the naive model, which is usually a baseline in time series forecasting, predicts tomorrow's price as being today's price. And so as you'll see here, when we compare our models, we'll plot this so it's much easier to see when we visualize them. The best performing model was an ensemble, but if you go back through the notebook, you'll probably see that the ensemble is actually just overfitting the data. And then the naive model is basically on par with all of the other deep learning models that we built. And here is the most interesting thing. The turkey model. Look at that. The error, MAE, mean absolute error, is off the charts compared to every other model. And what did we do? All we did was we changed one single data point. So this is what, it's very hard for, once you start to think about this, it's very hard for you to sort of believe any forecasting model ever again. In an open system, that is. In a closed system, in an open system like a stock market or an exchange or something like that, forecasting is largely BS. We've just seen that with the turkey problem. But in a closed system where you control all of the variables, such as like a computer networking problem or electricity demand or something like that, then forecasting will probably work there, or is much better to work there. But in an open system, it doesn't work very well. Because, as I said, you can have a model that predicts really well up until a single point, and then you lose all of your money. A turkey lives a great life up until day 1,000, and it becomes Thanksgiving. One data point can change your entire outcome. All right, so now let's start writing materials now that we've seen this firsthand. Does anything that I've said not make any sense? Because we can also have a look. Let's have a look at Taleb's book. Sally, I don't have a schedule for streaming at the moment. I kind of just jump on the stream whenever I feel like it, or if I have something to explain. How to learn from the turkey. Why don't we read this together, hey? Again, I don't know if this is copyright or whatever, but I'm sure you could find, you're smart enough to find this online anyway. This is the Black Swan book. Can you see this? I'm going to zoom in a bit. 1001 days, or how to not be a sucker. Let me move me up here, because I don't really matter for this one. Black Swan problem. Where's the turkey? Yeah, how to learn from the turkey. The Uber philosopher Bertrand Russell presents a particularly toxic variant of my surprise jolt in his illustration of what people in his line of business call the problem of induction, or problem of inductive knowledge. Certainly the mother of all problems in life. How can we logically go from specific instances to reach general conclusions? How do we know what we know? How do we know that we have observed from given objects and events suffices to enable us to figure out their properties, their other properties? There are traps built into any kind of knowledge gained from observation, right? So this is what we've done. This is the knowledge that we have gained from observation. We have the observation of Bitcoin prices from the last 20 years. So this is where you have to be very careful. We're getting a little bit philosophical here, but as we've seen before, we've already seen this with numbers on a page. So now let's get philosophical. What we're dealing with is observations over time. So just keep that in mind. Observations over time. That is our knowledge of Bitcoin prices. So if we go into the book, consider a turkey that is fed every day. Every single feeding will firm up the bird's belief that is the general rule of life to be fed every day by friendly members of the human race, looking out for its best interests, as a politician would say. On the afternoon of the Wednesday before Thanksgiving, something unexpected will happen to the turkey. It will incur a revision of belief. So this is another thing. Let's highlight this. This is what the turkey's observation of the past is. Wow, highlighting on Kindle on a Mac is shocking. This is terrible user experience. Every single feeding will firm up the bird's belief that it is the general rule of life to be fed every day by friendly members of the human race, looking out for its best interests. So we come back. What would we generally infer from this data set? Let's go back to it without the turkey problem. We go back to the price of Bitcoin, what it looks like without the turkey data that we injected to it. Here we go. Right, so what would we generally infer from the historical data of Bitcoin? We would say that it basically always goes up. Right? Is that a logical heuristic just by looking at this? We would say that it just always goes up. Okay, that's a simple rule. Historically, it's always gone up. Like, it goes down sometimes, but it basically always goes up. But then, if we come back, if we relate this to the turkey's life, it gets fed every day and it's having a great life. However, if we come back to our turkey problem, what if we had one crazy day where the price of Bitcoin just plummeted? Just like the turkey has one crazy day where it becomes Thanksgiving. Look at this. So based on the observations over the past, we would say that the price always trends up. We could not predict this crazy day, just like a turkey could not predict the fact that it's going to slaughter for Thanksgiving. So let's come here. We'll go to the next page. The rest of this chapter will outline the black swan problem. It's a black swan. So a black swan is an event that you can't predict, an unknown. My face is in the way again. Let me bring him over there. How can we know the future, given knowledge of the past? Or more generally, how can we figure out properties of the infinite unknown based on the finite known? Oh my goodness. Again, this is beautiful. This is poetic right here. How can we... I'm going to highlight that. So this is what I'm saying. Oh my God. This app is shocking. Just let me read a book. How can we know the future given knowledge of the past? So this is what I'm saying. This is debunking basically every tutorial you ever see on predicting stock market forecasting prices. How can you know the price of a stock in the future, which is the infinite unknown, right? It could be anything based on the finite known of what you only know. As we said before, you know this intuitively. The most significant events in your life are basically completely unpredictable. So keep thinking about that. Think of the feeding again. What can a turkey learn about what is in store for it tomorrow from the events of yesterday? A lot, perhaps, but certainly a little less than it thinks. And it is just that little less that may make it all the difference, right? As I said, historically, your model may have made you $1,000 a day for 10 years. And then you have one day, you lose $10 million. Everything you've ever earned does not matter because you lost $10 million in one day. Right? It does not matter how many times you get paid off. It matters the size of your payoff. Does that make sense? In a turkey's life, it has 1,000 good days. So every day it's winning a little bit. But it has one catastrophic day, Thanksgiving, the night before Thanksgiving, before it gets served up on a beautiful platter, and it loses all of those good days. This is what I think for investing, for forecasting, for anything. You can have one day that wipes out all of your good work. The turkey problem can be generalized to any situation where the same hand that feeds you can be the same one that wrings your neck. Oh! Back to our machine learning model. The same model that makes you money over 1,000 days of Bitcoin data could be the same model that fails to predict the one day that loses you everything. So it doesn't matter. I don't care how good your model is for the past 20 years. Can it predict this day? No, it can't. Same with this, right? Maxwell, who gave us this example, your model could model this data perfectly, but then this day comes and you lose all your money. Right? So let's go back. Consider the case of the increasingly integrated German Jews in the 1930s, or my description in Chapter 1 of how the population of Lebanon got lulled into a false sense of security by the appearance of mutual friendliness with tolerance. Let us go one step further and consider induction's most worrisome aspect, learning backwards. Consider that the turkey's experience may have, rather than no value, a negative value. It learned from observation, as we are all advised to do. Hey, after all, this is what is believed to be the scientific method. Its confidence increased as the number of friendly feedings grew, and it felt increasingly safe even though the slaughter was more and more imminent. Ooh! This is where it's going to trick you, right? It tricks you into thinking the poor turkey gets tricked, right? On all these days, it gets tricked into a deeper and deeper and deeper sense of security that life is going great and it's going to continue going great until this one day that it can't predict. So same thing again, if we build a forecasting model of the stock price and somehow we get lucky that our model is telling us, hey, the stock's going to go up tomorrow, so you should invest. And we go, yes, we get 1,000 days of paydays. We get increasingly more believing in our model. And then the one day that changes everything, our model fails to predict. Why? Because it cannot learn this data point based on the historical data. Let's go back. We'll finish. We won't spend too much more longer reading this, but I'm having fun with this. Its confidence increased. Consider that the feeling of safety reached its maximum when the risk was the highest. Oh, that is a problem. But the problem is even more general than that. It strikes at the nature of empirical knowledge itself. Something has worked in the past until, well, it unexpectedly no longer does. And what we have learned from the past turns out to be, at best, irrelevant or false. At worst, viciously misleading. Woohoo! So this is the most important figure. Is the turkey problem a surprise? It's the exact same thing that we've replicated here. The data point that our model cannot predict. So I'll let you read more of that before we get copyrighted. I'm not sure if we can, but this is a great book, The Black Swan. I highly recommend that. If you want to do any type of forecasting, be well and truly aware of this. So I just want to reiterate the line. Where was it? Something that has worked in the past until, well, it unexpectedly no longer does. And what we have learned from the past turns out to be at best irrelevant or false, or at worst viciously misleading. So our model could have worked for 1,000 days, for 10 years, right? And then it will mislead us because we fooled into believing that it can predict the most significant points, which is something like this data point. Now, let's start writing some information about this. Should Bayes be the go-to then in an open system? Well, it depends on what you mean by Bayes. I actually think no model should be the go-to in an open system. It's better to use heuristics. I'm going to go to the bathroom quickly, and I will be back. But I'm going to just let this photo sink in. This is what we're discussing, the turkey problem. Okay, so we spent the last half an hour or so discussing the turkey problem. We've seen some examples. Now let's get to writing about it. Move my face. Is this in the corner? That should do. And that should also do. Okay. So what can we say about this? Have we run this? Oh, and also if you want to see this explained by the author of the Black Swan, check this out. This is an actual stock price graph. Look at that. As this graph would say. You could build a model. You could make every day for whatever this is, 5 years. And then you get slaughtered on a single day. So watch this if you want a little bit more about the turkey problem. But here we go. So why forecasting is BS, the turkey problem. When creating any kind of forecast, I want to be very explicit about this. So I want to be careful of the language that I use. When creating any kind of forecast, you must keep the turkey problem in mind. I want to be very explicit about this. The turkey problem in mind. The turkey problem is an analogy for when your observational data, your historical data, fails to capture a future event which is catastrophic, and could lead you to ruin. The story goes, a turkey lives a good life for 1,000 days, being fed every day and taken care of by its owners until the evening before Thanksgiving. Is Thanksgiving one word? I'm Australian. We don't really celebrate Thanksgiving, but Thanksgiving, beautiful. That can be one word. Until the evening before Thanksgiving. Based on the turkeys, observational data, it has no reason to believe things shouldn't keep going the way they are. In other words, how could a turkey possibly predict that on day 1001, its life, after 1,000 how do you spell consecutive? Consecutive. It's a consecutive. It's going good. It's how you'd think it's spelled. It's not something outlandish. After 1,000 consecutive good days, it was about to have a far from ideal day. Right? Does that make sense? Maybe I could put an image in here. TK image, turkey problem. Yeah, so these are the points. Model only predicts based on data in its distribution. How does this relate to the price of Bitcoin? or the price of any stock, or figure in an open market. How does this relate to predicting the price of Bitcoin? You could have this historical data of Bitcoin for its entire existence and build a model which predicts it perfectly, but then one day, which predicts it perfectly, but then one day predicts it perfectly, but then one day, for some unknown and unpredictable reason, the price of Bitcoin plummets 100x in a single day. Of course, this kind of scenario is unlikely. But what it means, that doesn't take away from its significance. Think about it in your own life. How many times have the most significant events happened seemingly out of the blue? As in, you could go to a cafe and run into the love of your life, despite visiting the same cafe for 10 years straight and never running into this person before. The same thing goes for predicting the price of Bitcoin. You could make money for 10 years straight. Your model predicts when the price goes up or down. You could make money for 10 years straight and then lose it all in a single day. Does that make sense? Image, turkey problem. Then we could go model. It doesn't matter how many times you get paid. It matters the amount you get paid. Does that make sense? So what I'm saying here is it doesn't matter how many times you get paid. So over the 10 years of Bitcoin, you could make $100 every day. But then you lose 10 million in one hit. Vice versa, you could lose $100 every day, but then make 10 million in one hit. So that's the bleeding strategy. So we're up to here explaining the turkey problem. Where do I want to bring this down here. in one of the last streams, we also had a great comment by Unstable Deuce. Last week's massive drop in BTC price was given by the CCP's legislative action. I know of no way to have the model predict or properly handle that. Yes, what I'm saying is the most significant events are unpredictable. I don't know if I can get more explicit than what I've said here. Let's reread this. When creating any kind of forecast, you must keep the turkey problem in mind. Detox Mungo, what's good? Algo trading? No. I haven't tried that. Pseudo Maze, hey, what's good? Oh, that's a good emote. Good to see you. Algo trading, avoid. It's basically playing slot machines. The Tattoo Technology says, this is like a general life lesson about diversifying investments, right? Yes. Because regardless of an algo or manual trading, this risk exists. Yes, you're entirely right. So it's important to know that regardless of whether the Tattoo Technologist has a great point here, I'm just going to discuss this. I want to bring this quote onto the screen so maybe other people can see it as well. I'll just do it here. I've got a bunch of quotes that we can go and have a look at later. But you guys are smart enough to know that the text is all we really need to discuss. So this is what we're talking about. This is like a general life lesson about diversifying investment rights. Because regardless of an algo or manual trading, this risk exists. Yeah, so the danger here is that the real danger here is that we're basing the future off historical observations, right? However, there is no way that based on historical observations, there is no way to predict the unknown unknowns, right? And often the unknown unknowns turn out to be the most significant events, purely because you cannot predict them. So whether you're using an algorithm to trade or whether you're manually making any sort of investments, this risk is still going to exist. So I'm highlighting this in the case of machine learning because this is what this specific project of, but the Tattoo Technologist is completely right, is that even if you weren't using an algorithm, it's still going to exist in your daily life. However, what people can get caught up with is the way machine learning is kind of portrayed is that it's magic. And so when you hear of someone they're using machine learning to predict stock prices, because of how the media portrays it, it's like they think that the model is, it knows something that other people don't know, right? But no model can capture the most significant events in the future, right? So although we're focusing on it from an algorithmic point of view, it also exists whether you're not using an algorithm. But I would also argue you could just say that the heuristic you use to invest is also some form of algorithm because you're just applying a set of rules to how you invest. So looping back, the Tattoo Technologist is right. Diversify your investments. Why? Because if a turkey problem occurs in one kind of investment, well, then you've got another option in, fingers crossed it doesn't happen to your other investments. Put it that way. But the turkey problem can also happen inversely, right? So this goes inverse. So you could lose money every day. I need to flip this image. Lose money every day and then have a ridiculous payoff in one day. So that's something to also keep in mind. But what we're trying to do is that you can't make money if you have none, right? So it's better to avoid ruin, avoid going to zero. That's what we're trying to do. We don't want to go to zero because it's hard to make money when you go completely to zero. So, yeah, I like that quote. So let's keep writing here. Let's finish this off. I think now, after this point, we will... I'm going to write this down here. In this video here. Resource. If you'd like to learn more about the turkey problem, let's explore this and how it relates to our predicting the price of Bitcoin. Let's explore this. Let's get specific. Let's get specific. And see how the turkey problem affects us modeling the price, the historical and future price of Bitcoin. Okay, here we go. If you'd like to learn more about the turkey problem, I'd recommend the following. Let's get specific and see how the turkey problem I really want to show someone why forecasting is BS. This is largely why forecasting is BS. There we go. We'll come back to that in a second. Resource, I'd recommend the following. There's a video by Nassim Taleb. We're going to copy this. Great video. Put in a little... I want to get the emoji. Has what I've been saying make sense? Because it makes sense in my head. When you first come across this concept, it might not like make intuitive sense, but then like once you start to relate it back through different analogies in your own life, and you sort of start to think about it more, it goes. It's hard not to look at anything like anything forecasting like this again. And I also want to link Mark's tweet here. Open system, beware. It's basically like fortune telling. We'll have a look at that in a second. We'll just get these resources here. I'd recommend the following. Now this is by Nassim Taleb. And also the Black Swan book by Nassim Taleb. Especially chapter 4, which outlines and discusses the turkey problem. See, if I use a capital T, people might think it's the country. But that's a whole new can of worms. The Black Swan. There's a book. There we go. The impact of the highly improbable. So, as we said before, for the price of Bitcoin to drop 100x in a single day, it's highly improbable. However, that highly improbable chance also could destroy everyone's portfolio for even if they've made profit for the last 10 years. So that's the point of the Black Swan. The Black Swan. No, we want this italics. Have I heard of Teammate? I'm not sure what Teammate is. Okay. If our model is created out of the assumption of the normal distribution, how could it ever pick up a turkey problem event? It's true. There's another article here. This is a good article. What's Teammate? I haven't watched Mark's latest ML Ops vid. No, I haven't. Yeah, so this is a great article. Black Swans, normal distribution and supply chain risk. Yeah, so we're dealing largely with psychology here. Oftentimes you'll see the normal distribution, which is often called the bell curve. Let's have a look at one of those. If you've done any machine learning, you've probably seen this, or statistics, normal distribution. What it's saying is that events, as you get further away from the mean, so this is the mean in a normal distribution, as you get further away from the mean, the chances of those events happening are rarer and rarer. So each one of these is a single standard distribution. Something like 95% of, 95% of occurrences happen within 1.96 standard deviations of the mean. That number is this, 1.96. Wikipedia, there we go, 95% of occurrences if you're assuming a normal distribution. However, let's say this is largely, we're going off a bit off tangent here, but why not? Let's just run with it. 2 sigma. This is why I believe 2 sigma are called 2 sigma. It's because they inherently know that they're like a financial science, right? Look at this. This is science, financial sciences, right? Okay. Our favorite deep learning papers from, what are they saying? So this is a company, why are they called 2 sigma? I believe it's because they believe the world is probably a normal distribution. They know that their models can predict these type of events pretty well, which is great, right? 95% of the events. However, what if you had an event that's like 8 sigma? So like out here. So the under the normal distribution, the chances of an 8 sigma event happening, I'm not going to calculate that, but someone know what that is? What are the chances of an 8 sigma event? By the way, what does sigma mean? Sigma is this symbol for normal distribution. What are the chances of an 8 sigma event? Yeah, how unlucky is a 25 sigma? Just tell me how long. Yeah, okay. Look at this. 8 sigma event. That is a tiny, tiny, tiny number. Okay? So really, really unlikely. But again, the really, really unlikely events are the ones that sting you the most. Or, this could work inversely, it could make your biggest payoff. As I said, you could walk into a cafe you've been for 10 years and run into the love of your life and be happily married ever after. So, that's my little riff on why 2 sigma is called 2 sigma. Hopefully someone in there knows that events outside of 2 sigma are very hard to predict with machine learning. What do we got here? Few shot learning. Do we have anything on forecasting? Oh, how does mix-up help with robustness and generalization? I like that. Oh, this is a cool post, actually. I'm going to read this later. ML. And I'll also save this later. ML. Okay, we're getting off track. Let's go back and finish this writing that we're doing. The Black Swan, Thanksgiving, Bitcoin price, etc., etc. Although unlike the turkey problem, if you don't sell coin stock, you have a historical likelihood of recovering. I guess the real challenge for ML-based trading is understanding when to buy and sell rather than predict the price. Yeah, so there are things you can do for trading, like when to buy and sell. You can have stop losses and stuff like that, but we're not getting into that. We just want to really just focus on the epistemology of the turkey problem itself, and just show how your model can fall to pieces based on a single data point. I'm going to get rid of all of these. And I'm going to move this down here. I'm not sure. I think this kind of like hits this might hit some people wrongly, because they think like forecasting is like some sort of special superpower. I don't know. Let's create. And I've got some ideas actually. So right now, all of the course materials are in notebooks. I'm going to turn this into a book after the course is done. So look at this. And notebooks aren't really, they're good to run code and explore and stuff like that, but it really needs to be, like, there's a lot of information in here, and that you can't really search these. So I'm going to turn the whole course into a book after it's finished. Let's get specific. So to do so, we're going to manufacture an extreme data point into the historical. No, well, how can we? Is extreme the right word? To do so, we're going to manufacture an extreme data point, an unlikely, a highly. Let's just call it highly unlikely data point into the historical price of Bitcoin. The price falling 100x in one day. Okay, very, very, very unlikely, but this is just to illustrate again of based on your historical data. It's unlikely based on the historical data. Same thing with a turkey meeting its demise after 1,000 days of eating delicious food. Wonderful. So here, notice the last price, the last value is 100 times lower than what it actually was. Remember, this is not a real data point. It's only to illustrate the effects of the turkey problem. Do we need an extra timestamp? Bitcoin timestamps, turkey, NP array. What are we doing here? I don't think we do. No, we don't. Get the time steps for the turkey problem. Now we've got Bitcoin prices. Turkey problem data point. Let's get the time steps. Run that. Check the last 10. We can do that in the same line. Save a single cell. And beautiful. Let's see our artificially created turkey problem, Bitcoin data. Okay. Wonderful. So the price is going up, 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 up. Plummets 100x in one hit. How do you think building a model on this data will go? Remember, all we've changed is a single data point out of our entire data set. Before we build a model, let's create some windowed data sets with our turkey data. Yeah, Pseudomaze, feel free to share a link. You said teammate? I'll have a look at that later. It looks pretty cool though. You said Mark uses it in It is. There's a Gaussian bell curve. I know this. This is from the book. What would I search here? It's somewhere in the book, but that is brilliant. If you've read The Black Swan, you'll know where this comes from. Okay, let's go on here. Building a turkey model. Oh, that's your note. Who gave that to you? Did Mark give that to you? Let's see how it affects our model. That is a beautiful gift. Okay, so now we're doing... The man, the myth, the legend. Is that Mark that gave it to you? Hey, Sauceman Sandbus. Here from YouTube. Love the vids. Oh, thank you, my friend. Welcome to the stream. Wait, there's another link? I'm very sad. I'm not sure who this is. No, I don't know him. That's not... You're kidding me. Number 5 gave that to you?
I want to tell you about a very famous...
You know what? I'm sad I'm not even subscribed to this channel.
I want to tell you about a very famous number.
I'm going to start binging this channel. I have seen these before. That is amazing. I'm going to watch this. I'm going to watch this later. Thank you for that. That is amazing. All right, let's watch a little bit. Oh, my Twitch chat is broken.
In 1963, if you wanted to do calculations, you had a mechanical calculator, like this wonderful Odner Brunsviga, but it's all mechanical. This guy, 1962, 63, Bob Reagan, worked at Frieden Incorporated, maker of mechanical calculators, had the site, and I've been lucky.
Okay, he sounds like my type of dude. Okay, and looks like our error matrix go through the roof. And with just one value change, our error metrics go through the roof. To see this, to make sure, let's remind ourselves of our model 1 went on by changing just one value our turkey model's MAE increases almost 30x over there we go. Okay, now we need to finally boom. So we see the preds, and then we're gonna put in here, might just put this down on different lines. Now, why does this happen? So Sourceman Sandbus is asking what happened. So to create the turkey data here, Sourceman, we took the original Bitcoin price data. So this is the original data, made a copy of it, and we changed one value. We decreased the final value of the Bitcoin price historical data by 100x. So this is just to exemplify the turkey problem. A very unlikely case of the Bitcoin price dropping 100x in a day. Who knows, it might. And yeah, as you can see, drops 100x in one day. So typically the price, or normally the actual price is around here. But to illustrate this point, we dropped it by 100x in one day. So then we built a model on it, and we saw that a model trained on with unmodified data will get an MAE of around 568. Whereas the turkey model, by changing one single data point, we have increased the MAE by 30x. So why does this happen? Let's think about how we can discuss this. The normal distribution, often called the bell curve, is probably the most commonly used probability distribution. But if you assume that is a good explanation for what you are observing, you are making certain inherent assumptions about the probability of future events. For example, with a normal distribution, the chances of extreme events are very, very low. Yes. So if we consider the fact that the models that we've built have been based around a normal distribution. So there is no way that a model will consider this type of event to be possible, because they are made with the assumption that our historical data has come from the normal distribution. So this type of event, if it's not included in the distribution the model is built for, it cannot predict this in the future. A model can only predict from the distribution of data that it was trained on. And especially with the normal distribution, the chances of extreme events are very, very low. Then they give an example. This is all from this article, Spend Matters, by the way. This is a good article. I like this one. So on British TV recently, we saw an interview with a lady from the north of England. When my house got flooded in 2014, they told me it was a once in 100-year event. Then it happened again in 2015, she complained. So this is what I'm saying. With forecasts, you could say it's a 1 in 100-year event. But that still means it could happen next year. It's a very unlikely event, but it still could happen tomorrow. That sounds like changes in weather patterns have blown that old probability model out the window and into the floods. Perhaps climate change means the norm in terms of volume or severity of rain has changed, and our victims should expect floods once every 10 years or even more often. The model is out of date. And the tattooed technologist, this is a comment from before. This is like a general life lesson about diversifying investments, right? Because regardless of an algo or manual trading, the turkey risk still exists. Yes, you're entirely right. So let's write about a little bit about this graph while it's happening. Probably just a remix of all of these different quotes, just to explain it as straightforward as possible, and then link to extra resources if someone would like to be informed more. Do we have anything else we want to include down here? No. Okay. Why does this happen? Why does our model fail to capture the turkey problem data point? Think about it like this. Just like a turkey who lives 1,000 joyful days based on observation alone has no reason to believe day 1001 won't be as joyful as the last. Think about it like this. Just like a turkey, think about it like this. Just like a turkey who lives 1,000 joyful days. This is kind of reiterating what we're saying, but I don't mind that. We've said this before, but I just to drive this point home. A model which has been trained on historical data of Bitcoin, which has no single event where the price decreased by 100x in a day, has no reason to predict it will in the future. A model cannot predict anything in the future outside of the distribution it was trained on. In turn, significant events, upward or downward, in turn, highly unlikely price movements, upward or downward, will likely never be part of a forecast. However, as we've seen, despite their highly unlikeliness, these events can have Let's do it real to Leb style. Huge impacts to the performance of our models. Does this make sense? We'll bring this down here. Why does this happen? Why does our model fail to capture the turkey problem data point? Think about it like this. Just like a turkey who lives 1,000 joyful days based on observation alone, has no reason, I don't think I need a comma there, has no reason to believe day 1001 won't be as joyful as the last. A model which has been trained on historical data of Bitcoin, which has no single event where the price decreased by 100x in a day, has no reason to predict it will in the future. A model cannot predict anything in the future outside of the distribution it was trained on. In turn, highly unlikely price events, price movements, upward or downward, will likely never be part of a forecast. Where highly unlikely is based on historical movements. Despite their high unlikeliness, does that make sense? Despite their high unlikeliness, I'm just going to say, despite their unlikeliness. Is unlikeliness a word? Unlikeliness. I don't really care if it's not. Yeah, beautiful. These events can have huge impacts on to the performance of our models. Makes sense. Oh, Ashik, what's good, my friend? Whoa. Team. I've ignored the chat for a little bit. I had to write a paragraph. I think that makes sense. And then I'm going to link here some more resources if people want to learn more. Here we go. It's like the model assumes a certain continuity in the way of future data. Very interesting. Yes, you're totally right. The tattooed technologist says, is this also a lesson about understanding the data you train the model on? E.g., if you had data for the lives of many turkeys over many, many Thanksgivings, then this would be predictable. But if it is limited to only a single turkey's life, it wouldn't be. So the tattooed technologist, yes, you're right. So I would argue that if you have, what the tattoo technologist is saying here is that if you had a model that was trained on many thousands of turkeys' lives, you could probably predict a pretty good model to know that the turkey gets slaughtered around 1,000 days for Thanksgiving. However, we're talking about this from the turkey's point of view, which is our point of view as investors. So I also think that for an open system, so I would argue that then becomes a closed system. Why? Because we know the turkey's start and end point. Whereas in an open system, we don't know what the end point is. Does that make sense? So if we had 1,000 turkey lives and we trained a model to predict how the turkey's life was going to go, for the first 1,000 days, the model would probably predict that the turkey's well-being is going great. But then, because we have the end point of 1,000 examples, we would expect our model to be able to predict that the turkey's life is going to come to an end after day 1,000 or something like that. However, in an open system like a stock market, there is no end point. Like, it keeps going. So even if we had a model that could predict the price of stock on 1,000 different stocks, none of them end. So we could have one that goes bust, but then another that goes up. So does that make sense? So I would say once we have enough data of turkeys' lives, it becomes a closed system because we know the start and end point of the system. Whereas a market can never be closed system because there is no end point. And also the turkey problem itself is from the point of view of the turkey rather than an external operator. Hey, Hasmonator, what's good? Benedict Neo says, hey, Daniel, a big fan of your channel. Oh, first time. You know, there's a cool thing on Twitch now that it shows me when someone's a first-time viewer. That's very cool. Thank you. Welcome to the stream. Hasmonator, welcome to the stream as well. Ashik, good to see you all. I think that is enough for the turkey problem. I think that as long as everyone here understands what we're talking about, I don't think I need to add any more. I'm just going to put here, if someone, let's write this. To get more technical, if our model is initialized and trained using a normal, which is a Gaussian distribution, slash uniform distribution, in turn, it then makes the assumption that our data also comes from these distributions. Yeah, should we put that in there? I don't know. And in turn, because then we kind of have to get into explaining the Gaussian and why with the normal distribution, significant events, normal distribution. I'm going to just add more as an extension. I think we've covered enough here. Right, so the Gaussian, the problem with the normal distribution or the Gaussian distribution is that the further away you get from the mean, the more unlikely the event. However, the real world is not normal. I'm not going to get into that. I'll let someone read the Black Swan if they want that. Or if they want Nassim Taleb's technical book is also really good on that. We've seen this intuitively. This will spark enough interest in someone that they can do their own research. Okay, let's put a resource here. That's just what I'm trying to do here, is spark enough research for someone to go out and learn more on their own. Resource for a great article which discusses the Black Swan, should I call it that? Black Swan events. I might put this here. Black Swan events. So I might also just put this here, a note. Put this as a key. Note, a very unlikely and unpredictable event, such as the price of Bitcoin falling 100x in a single day. Note, unlikely, the adjective unlikely arises based on the observational historical price changes of Bitcoin. The adjective unlikely is also referred to as a Black Swan event. A Black Swan event is an unknown. You have no way of predicting whether or not it will happen, but these kind of events often have a large impact. And let's just look up Black Swan event. There we go, Black Swan theory. So this is a little bit, this is just philosophical here, but very important. Note, an unlikely and unpredictable event such as the price of Bitcoin falling 100x in a single day. Note the adjective unlikely. So when I say unlikely, unlikely is based on the historical date the price changes of Bitcoin. Unlikely is based on the historical price changes of Bitcoin. Is also referred to as a black swan. I'm going to put that in bold. Black Swan event. A black swan event is an unknown unknown. You have no way of predicting whether or not it will happen. But these kind of events... Okay, that's good. Now we're going to finish this off. Resource for a great article which discusses black swan events. In the book, Taleb not only explains some of the psychology behind black swan events, but also describes some of the mathematics. One problem that he identifies is that experts often made the assumptions about the underlying world they are trying to explain. One way they do this is by assuming that observations come from a particular statistical distribution, which is then used to predict future events. Yes. Which discusses black swan events and how they become ignored how they often get ignored due to the assumption that historical events come from a certain distribution and that future events will come from the same distribution. Oh, there we go. That's a good way of describing that. See by Spend Matters. I like this article. Maybe I should turn these into actual articles on themselves rather than just in the middle of some sort of notebook. As I said, once the course is finished, I'm going to turn it into a book. That way it'll be searchable and the code it won't just be hidden in notebooks. So that'll be a future stream actually. Let me know if you want to see that on stream. Turning all of the notebooks in this course into a readable online book. Wonderful. Okay, we're going to get rid of all this. Okay, what's the chat saying? Is it possible to deploy a model using a cloud GPU? Yes, it is. Time series is huge. Seems like we'll be learning more than just machine learning. For instance, the behavior of the model. And of course, we can't really use the model in the real world as we did with other models in our section. Yeah, this is quite exciting, like for NLP a month ago. Rather than getting around on it, I'm happy to wait for the videos to get dropped and you kick me with curiosity to go forward and dig deep. Yes. Oh, so cool. Thank you, Ashik. Okay, I've got to do another bathroom break. I'll commit this to the GitHub. That way everyone will have the updated version. If you want the code, it's now in GitHub. And the turkey problem. Annotations. Add annotations for turkey problem data / turkey problem model. See, and look, if you try to load this, there's the notebook in the chat. If you try to load this on GitHub, it's actually not a great experience. So I'd rather do something that works a lot quicker. Yeah. So see, this is very long, right? There's a lot going on here. I'd like it if it was searchable. And I might give a little highlight of what I've been working on in a second. That way you'll see what I mean by turning the course into a book once it's finished, which will be very soon, actually, probably within the next week. I'll be back. Sheik says, woo, like the fast book? Yes, you'll see in a second. I actually just forgot that I didn't even update the Twitch stream of what we're doing. I can't edit my stream info? Oh well, I'll edit it later. Oh wait, no, here. Edit stream info. Predicting the price of Bitcoin with deep learning. And discussing the turkey problem in forecasting. Discussing the turkey problem and why using machine learning models for forecasting is BS. Okay. So how long have we been going for? Almost 2 hours. Okay, we're going to finish off the notes here. This is just lastly comparing. And I'll do these behind the scenes, the exercises and extra curriculum. That way it's a little bit more entertaining for the stream. But let's get out of some things. I'll be back. I'm going to go get a drink and we'll finish off the stream. And I'll also show you a little bit something I've been working on. I'm making turn the course into a book, so it's not just a hard. It's not just all through a repo, which is actually quite hard to read. So, be right back. Team, as always, the stream is sponsored by San Pellegrino. It's actually not sponsored by San Pellegrino. But if anyone from San Pellegrino ever watches this, I will drink your products on stream as much as you want. Actually, not really. Probably 1 bottle a day. Too much of anything is not recommended. Delicious. All right. So let's just finish this off. Compare models. Note. Let me put in a little key here. Oh, thank you, Ashik, for putting this in the ZTM Discord. So, we've trained a bunch of models. And, if anything, we've seen just how poorly machine learning models are at predicting deep learning and machine learning and deep learning models are at predicting / forecasting. Let's say forecasting. We're doing forecasting. At forecasting the price of Bitcoin or any kind of open market value. I'm gonna open these little. Is this gonna fry me with the sun? No, it's not too bad. Okay. As I said at the start, this is not financial advice. And hopefully, you've now, you'll now have the tools to detect whether, hopefully you'll now have the skills, some of the skills required to call out BS for any future tutorial or blog post or investment sales guide claiming to have a model which is able to predict the future. This is where I want Mark's tweet. I'm going to copy this. And we want to save this as 10 Mark Seraphim tweet forecasting BS. I'm going to put this in the code images. Terminal. Now this will be in our images. Oh shit. What? Ah, I need to pull first. Enjoy, Maxwell. Thank you for tuning in. Enjoy the reading. I'd like to make that smaller. We can do that later. Think we're on here, team. I think that'll do. I'll come back and clean this up, but that is largely the materials for the time series module. Now, before we finish off this stream, who wants to spend 10 minutes or so having a look? I'll do the exercises and extracurriculum later. Up to here. Clean up, exercises, and extra curriculum. Who wants to see a little preview of a book that we could potentially make for the course? So let me just commit this just to make sure it's all there. Add text for comparing models. Sign off. Exercises and extra curriculum. Next. Beautiful. So the most up-to-date version of this notebook is now in the GitHub. Let's see. Let's pull it down. Clear. Let me just show you what I was looking at the other day. ls so now let's I was playing around with MK Docs, which is what you said before, Ashik. So if we have a look at docs, I've got some notebooks in here. And let's have a look at now. MK Docs. Gonna get out of this. So this is what I was using. Look at this. This is what I'm going to make for the course once it's finished. I need to activate the environment. ls. Source env bin. And then mkdocs serve. This is very cool. I'm going to hopefully, well, not hopefully, we're going to get this made another. Look at this. How cool is this? Welcome to MK Docs. So obviously I'll change the home page, but look at this. Getting started with TensorFlow, a guide to the fundamentals. What is TensorFlow? So look at all of this. Creating tensors, creating random tensors. This is amazing. Look at this. This is our book. So this is what I'm going to do. I'm going to have all of the books here, all of the notebooks here, and then it's going to be all of this. So if we have a look at this, I'm very excited about this. This will probably be a weekend stream. We could do this weekend actually. So every time I make a commit to the GitHub, so change one of these notebooks, I'm going to get it to rebuild these documentations, this documentation. So if we have a look at notebook number 1, look at this. It just converts the notebook into a beautiful, readable documentation. Right? And then one hot encoding, square root, yada, yada, yada. You can go right down to the next, and then you go to the next page. And then it goes to the, so this is just a playground notebook, but you could go back to this one. And then if you come over here, you'll have the home page, and you'll have this, and whatever. And it loads really fast. because it's just all text. And we'll even also be able to make it searchable. So this is what's going to... So I'm going to probably stream this on the weekend. Don't hold me to that. But this is what the course is going to be once it's finished. So you could imagine if I make a change to one of these notebooks, I'll just have this code automatically run in the background and it will update this documentation. And so now I believe we can make this searchable. Let's see if we can implement the search right now. Home, getting started, setup, search. Look at this, it works automatically. So we could probably do this live on stream. So let's have a look at this. Right, this is my current live notebook. It has no search bar. Let's create another terminal. So we're going to see if we can implement a search bar here quite quickly. So conda deactivate, ls cd code, material docs play. So look at all I've got. All I've got is a YAML file and I've got a docs folder. So if we have a look at what's in docs, right? So this is where the notebooks will live. Fundamentals, so this is this one. Getting started with the TensorFlow, a guide to the fundamentals. Index.md, which is the front page. So of course I could change this, right? I'll change this. And then here are the notebooks. So now if we go back, ls, all we have to do to add a search bar to this is mkdocs YAML. We're going to add a plugin here, right? So all we're doing is we're adding a plugin. This would be a fun stream, wouldn't it? Right? Setting up site search, all we're doing is adding a plugin. Search. So watch this. This is how cool this is. I could set this up to all work automatically in the background. No search bar here. So what I'm going to do now is escape, write these changes, and it should rebuild automatically. Look at that. Did you see that? It rebuilt it, and now we have a search bar. Let's search for absolute value. Oh, my friends. Look at this. Look at that. Why don't we search for matrix multiplication? Matrix multiplication tidbits. Boom. What else can we search for? Dot product. Oh. Team, we're going to build something amazing this weekend. We'll turn the entire course into a book, and we will organize it with GitHub Actions so that every time a commit is made to this repo, the book is automatically updated. We will figure out how to do that on the weekend, but this stream has been mostly dedicated towards talking about the turkey problem. Very important to understand that in time series forecasting. And also how a model cannot predict anything outside of the distribution that it was trained on. So thank you all so much for joining into the stream. I'm going to finish these off later, potentially in another tomorrow's stream. We'll start making the images that I need throughout this notebook. So if we see image, yeah, I've got a whole bunch of images that I'd like to create. So we'll start to create those. And then in a stream on the weekend, we will probably turn the course into a book like this. So yeah, thank you for tuning in. Twitch Live Lover, welcome to the stream, first time chat. Thank you for joining in. Thank you all for watching. As always, keep learning, keep creating, and I will see you next time. Watch out for those turkey problems.